Hey people, I'm Barros from 112ME, and in this video we're gonna tackle the basics of stoichiometry. So good day. I'm Barros from 112ME of UST, and in this video we're gonna discuss the basics of stoichiometry. Okay, so at first let's give ourselves a problem. So we're gonna have to convert 500 atoms of chlorine into moles of chlorine. So in stoichiometry, in a problem like this, you're gonna have a basic form of this. You have to put this into mind. What you got over 1 times what you want over what you got. So it's gonna be like this. We're gonna substitute 500 atoms of chlorine here, what you got, over 1 times what you want to achieve. It's moles, so we put 1 mole of chlorine, and to represent 1 mole of chlorine, you will have to use the Avogadro's number. This. So basically, this represents 1 mole of chlorine. So in order to get 1 mole of chlorine, you're gonna have to use the Avogadro's number. You need to have this. Okay, so when you type that into your calculator, you're gonna have 8.31 times 10 raised to the negative 22nd moles of chlorine. So this basically, what happened right here is, it's basically not that hard. So what you just have to put in mind is that what you have to put here at the bottom. And in this particular problem, we're using atoms and we need moles. So we had to use the Avogadro's number because the Avogadro's number is used for atoms. Okay, right here, atoms. For other problems like looking for the weight, or when you have the weight, you're gonna have to use the molar mass of the atom, of the element that you have. For example, chlorine, you're gonna have to use your periodic table and use the molar mass of chlorine and substitute it here. Okay, so we're gonna have that for the next problem. So like what I said earlier, we're gonna do a weight problem now. So now we're gonna have to get the mole of chlorine from 50 grams of chlorine. So remember that formula we had? It's what you got over 1 times what you want over what you got. Okay, so to start us off, let's substitute it again. So it's gonna be 50 grams of chlorine over 1 times what do you want? It's the moles of chlorine, alright? So we're gonna have a mole of chlorine over. So in this case, like what I said earlier in the previous section, we're gonna have to use the molar mass of the element that you're looking for, because this is a weight. You have a weight problem, and you have grams. Okay, so that's weight. So you'll have to use the molar mass of the element instead of using the Avogadro's number, because you can only use the Avogadro's number when you have atoms given. So yeah, so let's get that. And the periodic table, wait, let me check a periodic table. So it's gonna be 35.45. So this number right here is basically the molar mass of chlorine, and that's given in your periodic table. So when you input this in your calculator, you're going to have 1.41 moles of chlorine. There you have it. Pretty simple, right? Okay, so off with the simple problems, and let's do something a bit more complicated on this one. So we're gonna stick with chlorine because it's pretty easy. So we're gonna start with 500 atoms. Oh my gosh, not writing anymore. Okay, 500 atoms of chlorine into grams of chlorine. So this is a bit harder because you can't convert it one time. It's gonna be a 3-step instead of a 2-step like the ones earlier, and you're gonna have to multiply the 3 stuffs right here. Okay, so first, always remember that form that I told you earlier. That is what you got over 1 times what you want over what you got. This is very handy, this form. Okay, so now let's substitute 500 atoms of chlorine over 1 times 1 mole of chlorine over the Avogadro's number, because this one is atoms, okay? So you can cancel that out, and we're gonna use 6.02 times 10 raised to the 23rd power of atoms of chlorine. Okay, so that's it. But it's not yet complete, because when you cancel the atoms, it's gonna be moles. We just used moles because this is an easy bridge to get grams, okay? It's very easy to use moles because you can just use the weight on this one and the other one. You can use mole to cancel it out, you know? So yeah, so let's do the other one right here, the third one that I was telling you. Okay, so it's gonna be the molar mass of chlorine. Okay, let's put 35.45. Do you see the form? Over 1 mole of chlorine. Okay, so see the form? It's very similar to this one. Because first, we had to do this to get the moles. Why did we use moles? Because it's easy to cancel that out and just use 1 mole. We're just gonna put 1 mole here so that it cancels it out, and then you get the weight. Okay, what you want, right? Get it? What you want? It's grams of chlorine. That's the molar mass. And then just multiply this over this, because this is gonna cancel, 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 cancel. So it's gonna be 500 times this over this. It's pretty simple. So those are the basics, and your answer is gonna be, oh, let me take my scientific calculator. Okay, so the answer is gonna be 2.94 times 10 raised to the negative 20 power of grams of chlorine. Never ever get your signs wrong, because that can be your wrong answer. I learned a lot from that, yes. Okay, so that's your final answer. Okay, so this is going to be another step-by-step of a full-on stoichiometry question. So from the equation H2 plus O2 is to H2O, how much water should we get out if we start with 1 gram of H2 gas? So it means that how much water can we get out of a gram of H2 gas? Okay, so first step, we have to balance the equation. Okay, so to get this balanced, you'll need to multiply H with 2 and O with 2. Okay, because it's going to be 4:2, so you get that ratio. It's all about ratio here in stoichiometry. You get the proper ratio. So it's going to be 2H2 plus O2 is going to be 2H2O. Okay, and we're going to start off with, the mass is going to be 1 gram on this one, and the mass on this one is, we still don't know, because that's the question. Yeah, so how much water in a gram of gas of hydrogen. Step 2, we get the molar mass of the elements in this problem. So it's going to be molar mass of hydrogen gas, the ones in this equation, is going to be 2.02 grams per mole, while the molar mass of water, this is water, is going to be 18.02 grams per mole based on this equation. So step 3 is we get the number of moles of what we have, and what we have right now is 1 gram. It's 1 gram of hydrogen gas. So what we're gonna do is number of moles is equal to this over this is equal to 1 gram. That's what we're looking for, over 2.02 grams per mole. Okay, so applying to what we had way earlier, this is gonna be it. So yeah, see the formula, and it's gonna be equal to 0.495 moles. The fourth step is we take the ratios into account. So as you see right here, that's what the equation says. H2 is to H2O right here. It's gonna be a 2:2 ratio since we balanced the equation earlier, right? So 2:2 is also 1:1. Okay, so for every 0.495, it's just an example of water, so hydrogen gas, that's gonna be 0.495 moles of water. The last step is that we're looking for the mass. Okay, so basically from our equation earlier, where is that? It's NH2O. This one. This one. Where is it? This one. Yeah, this one. Step 3. From what that says, it's gonna be number of moles of water is equal to 0.495 moles. We're gonna use this equation to look for the mass, because they're asking how much water we're gonna get. So we're gonna use this equation right here, this formula, and we're gonna have 0.495 times 18.02. This one is the one we got here, the number of moles of water times the molar mass of water, basically, of H2O. So yeah, the answer is gonna be, let's equal to 0.495 times 18.02. That's stoichiometry, guys. Thank you for watching, and I hope you learned something out of this video. And yeah, good day.